Hi, welcome back to my YouTube channel. In this video, we're going to see how we should solve the indefinite integral of e to the ln x dx. So this integral is a little bit tricky and we need to use error function for that. So how should we proceed with that? Recall that we can write any number as e to the power of that number to the power of ln of that number. For example, in this integral, I can write it as e to the ln x to the power of ln x dx. This is the same thing as x to the ln x dx. Now, the ln x's are gonna go down and they're going to cancel out each other. So it's gonna be, they're gonna get multiplied together. So it's gonna be ln squared of x dx. So far we've gotten here. Now I'm gonna let t be equal to ln x, and ln is just the log base e of x, and we can write it also as e to the power of t equals to x. And if I differentiate both sides, I'm gonna get dx is e to the t dt. What did I just do? I just took the derivative of both sides with respect to t. Dx dt equals e to the t, and moved the t to dt to the other side like this. What I'm gonna do next is I'm gonna do this substitution here. So it's gonna be e to the t squared, and dx is e to the t dt multiplied by e to the t dt. I therefore is e to the t squared plus t dt. What I'm gonna do now is a little bit trickier, but I'm gonna just add and subtract a fourth here. Let me write it more clean here. I'm doing it so I can factor it out. So if I factor it out, it's going to become t plus half squared minus a fourth dt. Thus, I equals e to the, so this can be written as e to the t plus half squared times e to the negative fourth dt. This negative fourth can be factored out of this integral because it's a constant. It's going to be e to the t plus half squared dt. What I'm going to do next is I'm going to define u as t plus half, and du is going to be dt if I differentiate both sides. Now I here is going to be e to the negative fourth times e to the u squared. My dt is du. So now recall that the error function, because we need error function to define this creature here. Error of x. Error of x, let me write it from here because this is going to be pretty long. Error of x equals to 2 over root pi of 0 to x e to the negative t squared dt. Now, what I'm going to do, I'm going to say, what is erf of ix? I'm going to find, I want to make this t e to the negative t squared e to the t squared. Okay, now what I'm going to do next is I'm going to differentiate both sides of this equation with respect to x. And the formula for that, if you have a function, according to Leibniz notation, if I have a function defined as, if I want to take its derivative defined as a of x, b of x, f of t and x dx, its derivative according to Leibniz notation is b prime of x, f of b of x, x plus minus a prime of x, f of a of x, x, plus the integral of a to b, the integral itself, of partial x of f of t and x dt. So if you plug in all the things here, we're gonna get partial x of the inside this derivative here, which is with respect to x, and t to the negative t squared is a constant, thus the derivative of a constant is going to be 0. And the only non-zero component of this integral is 2 over root pi times I and multiplied by f of b of x and x, which is e to the negative ix squared. And f prime of ix is 2 over root pi e to the x squared. Now, if I integrate both sides of this equation, I'm going to get f of x. If I integrate it with respect to x, I'm going to get 2 over root pi I e to the x squared dx. And f of ix can be written as I f of x. Thus, I f of x equals to 2 over root pi I e to the x squared dx. The i's are going to go away, and f of x is going to be 2 over root pi e to the x squared dx. Now, e to the x squared dx is root pi over 2 f of x. So here we got the results in this integral as I to be e to the negative 1/4 times e to the u squared du. I can substitute it as in terms of error function as e to the negative 1/4 f of u. So I just forgot root pi over 2 f of u plus c, some constant of integration, and recall u to be t plus half. Thus I is e to the negative 1/4 root pi over 2 f of t plus half plus c, some constant of integration. Now I is e to the negative 1/4 root pi over 2, t equals ln x. Thus I can write it as f of ln x plus half plus c. Now I can make it more simple as 1 over the 4th root of e root pi over 2 f of ln x plus half plus c, which is equal to our integral that we first defined. Thus, the integral of x to the ln x dx is 1 over the 4th root of e Euler's number root pi over 2 f of ln x plus half plus c, some constant of integration. Thus, this is the form of our indefinite integral if you want to integrate this function with respect to x. So hope you enjoyed this video. Please like and subscribe, and I will see you next video.